Atoms cannot be counted by direct observation due to their tiny size. So how do we count them? We count atoms by weighing them. The significance of Avogadro's number is that 1 mole of any element weighs its atomic mass, but in the unit of grams. For example, the mass of one titanium atom is 47.87 AMU, rounded to 4 significant figures. This means that 1 mole of titanium atoms weigh 47.87 grams. This is known as the molar mass, which is the mass of 1 mole of a substance measured in grams per mole. We say that the molar mass of titanium is 47.87 grams per mole. Molar mass relates the mass of a substance in grams to its moles. Since we can measure gram quantities, the number of moles can be calculated directly in a single-step calculation using molar mass as the conversion factor. This is why the most convenient way to count is by moles. The conversions between mass and number of moles are very common in chemistry. You will be doing many of them, and you must be able to do them fluently. Molar mass is determined using the atomic mass values in the periodic table. For monoatomic elements, atomic mass is the molar mass. For molecular elements, the number of atoms in the molecule must be accounted for, such as nitrogen. Nitrogen is a diatomic molecular element, thus its formula mass is the total of 2 nitrogen atoms, which comes out to be 28.02 AMU, or grams per mole. For a compound, the number and kind of each atom must be accounted for. In octane, there are 8 carbon atoms, each with a mass of 12.01 AMU, and 18 hydrogen atoms, each with a mass of 1.01 AMU. Its formula mass is the sum of the masses of each element, 114.26 AMU, or grams per mole. When counting the number of atoms in a formula, keep in mind that parentheses group polyatomic ions. The subscript that comes after applies to the elements within the parentheses. In this case, there are 2 nitrogen atoms and 8 hydrogen atoms within the parentheses. Then the rest of the calculations are completed as usual. The mass of 1 sulfur atom and 4 oxygen atoms are calculated and summed up to give 132.17 AMU, or grams per mole. The mass of a given number of moles of helium is found using its molar mass. Molar mass of helium is obtained from the periodic table as 4.00 grams per mole. This means 1 mole of helium has a mass of 4.00 grams. The conversion starts by writing the given quantity, 0.411 moles. The conversion factor has the mole unit in the denominator and the gram unit in the numerator. The values come from the molar mass. 1 mole is equal to 4 grams. The mole units cancel, and the answer is 1.64 grams of helium. In a reverse calculation involving carbon dioxide, molar mass must be calculated first by adding the mass of each element in the compound. It comes out to 44.01 grams per mole. This means 1 mole of carbon dioxide has a mass of 44.01 grams. The calculation starts with the mass in grams. Thus, grams is in the denominator and mole is in the numerator. The values come from the molar mass. 1 mole is equal to 44.01 grams. The mass units cancel, and the answer is calculated in the units of moles. In these examples, the placement of the molar mass was different. In the first conversion, we multiplied by the molar mass, but in the second, we divided by the molar mass. However, if you apply dimensional analysis correctly, you don't ever have to memorize if you are going to multiply or divide. Setting up the conversion factor correctly will automatically result in the right setup.